Jeff said, my name is Remi. I'm a principal program manager on the CAT team, the Copilot acceleration team. My role is to work with customer and help them go live with Copilot Studio. I'm part of engineering, so I make the bridge between customers and our engineering team, and I make sure that everybody's successful. So for this session today, I want to talk about 3 new features, or relatively new for some of them. The first one is multi-agent orchestration. This is a feature that is in preview at the moment. It should go GA before the end of the year. This feature allows you to create multiple agents and connect them together, whether you build them in Copilot Studio or you build them outside of Copilot Studio. We'll see what's possible. You can connect those agents and make them talk together. So that allows you to build modular, composable agent architecture and allow reusability between teams. You might have a team working in HR, a team working in finance. You may want to connect those 2 agents together at some point. So let's see how this works in Copilot Studio. So an agent is made of components. Those components are as simple as a topic or knowledge, or they are a little bit more advanced. You want to bring Power Platform connectors, flows, prompts, and at the bottom we have some even more advanced tools that we're going to discuss today, MCP and computer use. All of those tools are managed and connected via the orchestrator, and that's going to be a key component in the discussion today. And for multi-agent architecture, we have 2 options. The first one is creating your agent as child agent and adding them directly into your agent. So you have a parent agent and child agent in it responsible for specific task. That's great if you want to just modularize some components, like a FAQ on HR, on FAQ for IT. You can add inline agent for simple tasks inside your parent agent. The second way to have a multi-agent architecture is to connect to external agents. Those agents can be built with Copilot Studio, Agent SDK, Azure Foundry, and Fabric Data Agent. Not all of them are available today. Some are on the roadmap, like the Agent SDK is not yet available. So today we're going to talk about mainly Copilot Studio Agent and Fabric Data Agent, as well as Child Agent. So before we dive into like the technical aspect of multi-agent architecture, it's really important to understand how we are able to orchestrate multiple agents. Multiple agents are only available in Copilot Studio if you turn on generative orchestration. Generative orchestration is a way for Copilot to understand the user utterance, generate a dynamic plan that is going to use multiple topics, tools, and knowledge, and orchestrate them in a particular order to accomplish a task, and then generate a unified response. And where does our multi-agent architecture fit? Well, a child agent or a connected agent are going to be considered as tools. They're going to have descriptions, they're going to have inputs and outputs, and the way that we can enable multi-agent architecture is by leveraging generative orchestration. So how are tools and topics orchestrated in generative orchestration? The description and the instructions of your different tools and topics are going to be key. So when you create an agent and it has to call other agents in a multi-agent architecture, you will have to write instructions. Those instructions are going to tell your agent when to call certain topics and actions and tools, including child agents or including connected agents. The way the large language model is going to be able to understand which one to use is by leveraging your agent instructions at the top level, and then by looking at the tool and topic name and description. Very important, especially the name of the tool. It's even more important than the description. And so people don't understand that. Generative orchestration can also go beyond just orchestrating other agents and tools. It can also decide when to use knowledge. That's something that we manage in the agent instructions as well.
The code pulled for our
agent response is going to be
make sure that,
the result of agent instructions and generative answer instructions if you are at a lower level, like inside a topic. Sorry, there is someone talking on the call and it's...
Yeah, I got it. I got it.
All right.
Yeah, I got it for you, Remi.
All right, thanks. Okay, back to our orchestration. So those instructions are not only to decide when to use another agent, but they can also influence the response formatting, and they can also influence how the agent is going to populate input and output of tools, including in connected agents and child agents. Finally, instructions can be used on, or descriptions of the tools and knowledge can be used to guide the agent on which knowledge source to use. But this is used opportunistically only when you have a high level or high number of knowledge sources. Otherwise, the agent, if you have a low number of knowledge sources, the agent is going to try to query them all. All right, so enough with the slide. Let's see a demo of connected agent in practice. I have an agent here that I built with Copilot Studio. This is a conversational agent that my IT department uses to keep track of the inventory of the different equipment that we have around the organization. So it keeps track of the inventory of laptop, the computer, the mouses, the screen, everything like that. In the back end, I'm using knowledge for my AT inventory in Dataverse. I have a stock policy that explains the minimum of order for each of my different equipment, the vendor we need to use for each equipment, and I have some knowledge as well to be able to answer some general question. So my stock policy agent is combining knowledge to understand what are the business rules with regard to stock policy and stock management. For example, I have an inventory minimum of 10 units, or Best Buy has a lead time of 6 days, and it has access to structured data to keep track of my stock. So my current stock, like how many stock or how many laptops do I have in stock? Here, it's pulling that data from my inventory. That agent is currently using a GPT-4o model because it's a retrieval agent, doesn't have to be very complex. I have some minimum instruction about that agent. When I ask a question, here's what the agent is supposed to answer. And that agent, it's a conversational agent. I will be able to reuse it in other agents if I turn that capability on. It's not on by default. So you have to go to settings. And in the settings, you have to allow connected agent so that when you create an agent out of the box by default, nobody can connect to it and use it. It's a maker decision to allow other people to be able to leverage your agent. So I turn that on because I want another agent to be able to use that one in a multi-agent architecture. The other agent that I want to show you today is an autonomous agent, because you can have autonomous agent reaching out to conversational agent to retrieve information. You can have, in a multi-agent architecture, different agent type. So you can have one that is conversational and one that is autonomous. It doesn't matter. And in fact, autonomous agents are autonomous by the fact that we define autonomous triggers, but nothing stops you from publishing an autonomous agent to Teams and allow user to ask questions in the chat. That's what we called hybrid agents. Anyway, in my scenario for my autonomous inventory agent, you can see here that I picked a different model. It doesn't matter if my connected agents are running the same model or not. Each runtime is completely independent. In my autonomous inventory agent, how do I connect another agent? Well, I go to the agent tab, and here I have two agents that are connected. One, we call it a child agent. That's the one that lives within my regular agent. It's considered as a component. So if you talk about ALM, that agent will follow your parent agent in the ALM process. However, I do see my stock policy agent that was created by another team. And this one is a connected agent. It has its own ALM on its side. In my autonomous agent, very important, I crafted some set of instruction. So in here, that's the key that makes multi-agent architecture possible. In my instruction, I say, oops, there we go. I clicked on the wrong thing. In my instructions, I say when to use my connected agent. I could rely on just the agent description. So the agent description is very important. That's what you see here. That's critical when you start having multi-agent architecture. The description and the name of the agent are going to be taken in account to know when to call those tools. But you can influence when the agent is going to use those agents in the instructions. And for some reason, instructions are gone. Oops. Let me just refresh my autonomous inventory agent here. I think I clicked a little bit too quickly on it. So that autonomous inventory agent is going to be able to leverage my conversational agent. If I can have the instruction, there you go. And I'm giving hints to my autonomous agent on when to use that other agent. And you can do that by / directing your parent agent to another specific agent. Soon, you can even do that in a topic. You can, in a topic, direct the user question to another agent. So that's how I'm going to be able to do multi-agent architecture. I allow my user to connect to that agent, and then I use that as a reference in my instructions. So in my instruction, this autonomous agent is going to be able to I'm going to run a test and explain to you what this is doing. So I'm going to take a pass trigger. This agent is triggered when I'm running low on stock in a particular equipment. So I can see my trigger here. We are running low on inventory for laptops. We only have 8 in stock. The unit price is this. The lead time is that. Vendor is Best Buy. So my agent, based on its instructions, know that when I'm running low on stock, I need to reach out to that stock policy agent to know what is the minimum of order. For laptop, the minimum of order is 20 units. And in my instructions, I say, hey, if the order is above a certain threshold in terms of amount, then you need to ask for approval of a user. So here you can see it's triggering approval. If I go to Teams, and of course, it's going to refresh. In Teams, I will have an approval waiting for me. There we go. It's here. I have an approval request for a PO for those new laptops. It's above the maximum threshold where the autonomous agent can just take the decision by itself. And here, if I go back to my autonomous inventory agent, I will see that the status of my order has been switched to approve, and it's going to order more equipment and send me an email. So here, my autonomous agent was able to leverage a conversational agent to retrieve information about stock policies that are managed by a different team. And then it's going to send me an email with the recap of that order. So that's a typical multi-agent architecture with autonomous agent calling retrieval agent. Another scenario is when we want to talk to agent not built with Copilot Studio. In Copilot Studio, you have the ability to pull agent from outside. For example, Fabric. Fabric, you can create data agents that are great at slicing and dicing and crunching huge amounts of data. And the Fabric agent, I can add it as an agent in my Copilot Studio. So I would just add an agent here. And in Fabric, I have 2 different agents. One that is connected to the New York City taxi data set, so I can ask questions about that. And another one about public holiday. When I add those agents in Copilot Studio, technically, it's not using the A2A protocol. It's using the MCP protocol. And you can see that in the detail. In the tool, it does mention that this is an MCP tool. So even though we are connecting to a third-party agent built in Fabric, we don't necessarily use the A2A protocol. We're going to use the A2A protocol for external agents that are not necessarily built on the Microsoft stack. So in the backend, MCP can be leveraged in a multi-agent architecture. So we are kind of mixing 2 different technology and 2 different patterns to have a multi-agent architecture. So in here, in my activity tab, you will see that when I ask a question, my agent is going to initialize the different agents that are connected. whether or not they use MCP protocol in the backend, and run the query to the right agent depending on the description of that agent. And you can see here, my New York taxi agent has a particular description. And when I ask how many taxi rides did we get in the most busy months, then of course, my orchestrator went and routed the query to the New York City taxi agent, which called internally a specific tool that got me the results of that query that was then bubbled up to Copilot Studio, and then Copilot Studio created that response out of the data of my Fabric agent. So it's really easy to do. You create an agent in Fabric, you can just connect it into your Copilot Studio, or if you're building agent within Copilot Studio ecosystem, same thing, it's just one click, one agent can connect to another one. All right, moving back to my deck. Couple of best practice when it comes to writing agent instruction, because for multi-agent architecture, you will have to refine your instruction. Use the tool name, use the agent name with the / in your instruction. That will help the agent know when to use what. When it's a conversational agent, in your instruction, define the constraint, the response format, the guidance, if you want to use a tool before generating an answer or not, if you want to use the email action, for example, do you want to use HTML or not, that you can put in your instruction. For actions and knowledge, name is even more important than description. So do name your agent with a meaningful name, use right description in a multi-agent architecture. That will make a big difference. And finally, for autonomous agent, it's very good, a good practice to have a sequence of action for each processes. So you can have multiple blocks of paragraphs saying, okay, if the user say that if the trigger says we are running low on stock, do this. Or if it's a conversational question from a user that is asking the status of an order, then do that instead. So you can have different instructions for different behavior across your different agents. If you want more information for generative orchestration and how to guide your agent in a multi-agent architecture, go on Microsoft Learn in Copilot Studio. There's a guidance tab. We just released a few articles over the summer on how to write your instruction for this kind of scenario. The second thing we want to talk about today is the model context protocol. We learned that large language model need help with complex API and connector. It's not always straightforward to connect to a connector and to know when to use that. So the model context protocol, it's a standard model, a standard context for AI model to be able to understand the different tools and knowledge that we show them. This is generally available. It has been since before summer. It integrates seamlessly with Copilot Studio, which just one click, we can add an MCP model. It will improve your developers' life and efficiency because instead of adding connectors one by one for different actions, you can have an MCP server that encompass multiple tools and actions that that the developers can take advantage of. And the best example for that is all the first-party MCP server that Microsoft released. If you were to interact with Outlook and emails, you will have to add each action one by one to reply an email, forward an email, list your different email. If you add the email management MCP server in your Copilot Studio agent, all of a sudden, we do user permission delegation, and you have access to all the connectors available for email management. So it's great from a developer perspective. MCP server can be extended. That's something that the developer of the MCP server will manage. Just like last week, we added the support of resources. That's something that was already there in the MCP protocol, but Copilot Studio did not manage that yet. Resources are to access relevant customer-specific content such as file, API responses, database records, and more. For example, here, I added the MCP server for Redfin. It's able to get me information on particular listing or on particular user account, just like an API would return that. So it's great for knowledge. If you want more information on why resources matter in MCP protocol, there is a link at the bottom of the screen, and I will drop it in the chat at the end, and you will get the presentation anyway. So the MCP versus traditional approach. Why do we care about MCP? Large language models are limited to static knowledge. They don't necessarily have access to external data. If you move to LLM plus a connector, then in this scenario, you do have access to external knowledge, but for each action, input and output, you have to describe that. You have to redo the connection. And if you use the same action in multiple copilots, then you'll have to do that over and over again. MCP will solve that. So MCP, it's a standard integration with description pulled automatically from the maker side, solving that repetitive task. How does it work? There are two parts of the MCP protocol. On the right, we have the MCP server exposing resources, tools, prompt templates. And on the left, we have MCP client that will query the resources, invoke the tools, and pull the prompts to be able to run them locally. If we take a look at each part of the MCP protocol, the hosts are going to be where we register the tool that the MCP is going to be using. So Copilot Studio is a host, but Copilot Studio is also a client. Copilot Studio can host an MCP server and connect to an MCP server and execute some logic. The MCP server are usually built outside of Copilot Studio, whether it's on Azure AI Foundry, with GitHub, with Dataverse, with Dynamics. We have a ton of first-party MCP server at Microsoft, but there are also a ton of external MCP server that you can pull into Copilot Studio. Seeing the most recent one is like the Salesforce MCP server that was added recently into Copilot Studio. So in Copilot Studio, you can pull multiple MCP server for different scenarios. In my agent, I may want to manage my emails and my calendar. In that scenario, I will add the MCP server for M365 and Outlook. And I may want also to add custom created MCP server. The best way to do that is to use Azure API with an API manager, APIM, and then create an MCP server out of that. It's a new service available on Azure. With a couple of clicks, you can create an MCP server on top of an API that is managed in Azure and expose that to Copilot Studio. I will show you a demo in the next slide. All right, so let's give a tour of the MCP, of an MCP agent. Not this one, this one. So I've created an agent, brand new agent, and that agent doesn't have any knowledge. I'm going to rely only on MCP for the different tasks of this internal agent that I created for my personal productivity and my team's productivity. The first thing that I added into that agent was Microsoft Learn MCP server. It's one of my favorite. You go to add a tool, go to the MCP, and then here you have like a list of existing MCP server. The one that I really like is, where is it? It's here. The MCP Microsoft Learn documentation. Why is it better than adding Microsoft or learn.microsoft.com as knowledge? Well, the MCP is responsible for the indexing. So we built an entire server to ingest Microsoft Learn, and we run a semantic indexing model on top of them, on top of all the Microsoft Learn content, which is much more interesting than just adding Microsoft Learn in knowledge, because if you're familiar with knowledge and public website, we are delegating the query to the Bing API. So Bing is responsible to index Microsoft Learn, which it does, but Bing doesn't necessarily do a semantic indexing. It's relying on keywords to search in its indexes. When we turn to the MCP server for Microsoft Learn, we will have much more detailed answer and much more precise search. So let's give it a try for the Microsoft Learn MCP. So when I send a question to my agent, you can see it's instantiating or initializing all the MCP servers on that agent. Why? It's because at runtime, we are going to pull, if I go back to my tools, we're going to pull the different resources available inside those MCP servers. So you can see here the part where it says tools. This is actually pulled at runtime. So if between yesterday and today, somebody added a new functionality in my MCP server for Microsoft Learn, that will be automatically fetched by my agent. And then I can take advantage of it instantly without to reconfigure my agent or re-add that endpoint in the connector inside my agent. So the activity will list all the agent, initialize each agent. You can see my Microsoft Learn, it's running the internal indexing tool to get all the tools available. And then my MCP server tell me, okay, you can fetch documentation. Oh, you can fetch code sample. That's great. If I add learn.microsoft.com as knowledge as a website, I won't get code sample because they are not necessarily well indexed by Bing, because sometimes they are hidden behind accordions, and Bing does not index the content behind accordion that are hidden by default on a web page. Let's give it a try. So here I was able to ask a question by my SAP connector, and you can see that it's fetching the information and it's giving me inline citation just like I would have for my website. So if I click here, the SAP OData connector, I click on it, it actually takes me to the SAP OData connector piece, and it can even go to a particular anchor inside the documentation, which is something that is not possible by adding the website in Knowledge. It just go to the top of the page. With the MCP protocol and Microsoft Learn, you can go to a direct anchor inside the page. So it's much more precise. Let's go ahead and ask for a code sample for the agent SDK integration with Copilot Studio, something that would not be possible to get through Microsoft Learn as a website. And here it's able to get me the code sample and get me the code sample inside Copilot Studio. So you can see how much details we get by leveraging a first-party MCP server that has all the, the code snippet functionality with the color coding and everything. All of that is built in the MCP server and the protocol integration with Copilot Studio. So in my opinion, it's just worth for that. If you have a website and you want to index it and show that, expose that to the rest of the world, MCP protocol is a great, the model context protocol is a great way to do that. I added other tools, other MCP protocol in my agent. So let's restart the conversation just to be clear. The second one I want to show you is, hey, I have an email management server. So if I ask list my 3 most recent email, it can find the right server. Again, it initializes the top 3, all the servers to fetch the different tools, and then it finds the list email tool, and it's able to get me those different emails. And since the email management MCP server has a lot of tools and action that I can take advantage out of the box, I can ask, like, can you flag the first email? So here I'm asking the agent to take in account the conversation context, understand that I'm talking about the first email of the most 3 recent, and I want them to message or to flag my my message. Okay, the first email. Will it be able to understand? No, it didn't work. So hit or miss. Sometime it will work great. Sometimes it won't, and it leads to a bigger discussion. Right now, if I add an MCP server to my agent, the description of my tools and the input for each tool, the responsibility is for the developer of that tool. I cannot change those descriptions here. So for me, it's one of the biggest limitations, because in this demo, for example, when it fails, I would love to be able to go in my tool and add some more explanation to the large language model on where to get those information missing. You can add that in the top level instruction. I didn't do anything because it was working fine up until the demo, of course. But technically, you can influence how the MCP is used in those instructions at the top. Hopefully, at some point, we will add the ability for developers in Copilot Studio to supplement description of the tools available in an MCP server. That's something that we are looking at. I don't know if we will have a particular timeline for this. But all right, let's try again if we are a little bit more lucky.
Hey, Remi, just giving you a time check.
Fantastic, thank you. So listing my top 3 email, and I'm going to say, all right, I get my 3 email. Okay, that's the laptop I ordered in my demo. Flag the first one. Is this going to be able to understand? No, it's not able to understand the message ID. The first email. Anyway, technically, I was able to flag my email, forward my email, do all kinds of action on my personal inbox because the MCP server for email management use permission delegation. So that's great. As an end user, I can manipulate my inbox through my MCP server. The last one I wanted to showcase today, before we talk about creating our own custom MCP server, is the first-party MCP server for Dataverse. So this one has a list of tools. You can see here, it can list table in Dataverse, describe the different table, create record, update record, all of those complex functions. Like if you want to, insert a new record in a table in Dataverse using Power Automate or using an agent flow, you will see that it's a challenge. You have to take a lot of things in consideration. Using the Dataverse MCP server will abstract that complexity. And for example, if I ask something like getting a query about a specific table, and I want the knowledge inside that table, and that table is in Dataverse. So remember the stock policy agent that I had? This stock policy agent runs on top of a Dataverse table. Through my Dataverse MCP server, I can ask questions about any table that I have access to as a user. So here I'm asking, what is the stock level for the different equipment in the IT inventory table? So it took a few actions to find out the answer. The first is list all the table in Dataverse, because this one, the IT inventory table, is a custom table. Then describe that table to understand the schema, what are the different columns, and then generate a query and read from that table. And you can see here, it's dynamically generating that query, and it's showing me what's happening in the backend in that MCP server. It gets me a payload in the form of JSON, which is then bubbled up to the orchestrator and the large language model in it. And you can see it gives me a breakdown of my IT inventory table, and I can ask all kinds of questions like update that table, delete that. I don't think, not sure we can have a delete action, but you can update, you can create records. Can we delete? Yeah, we can delete stuff. So the Dataverse MCP server it can be dangerous because we allow a ton of action on top of it. So MCP server in the backend are custom connectors. So if you want to block certain functionality of those MCP server, you can through DLP, okay? But if you want to block, for example, the Dataverse MCP server all at once, we just introduce a configuration in the Power Platform Admin Center at the environment level. So as an admin, I feel much more safe if I turn the Dataverse model context protocol server for like developer environment. I don't want necessarily like people to go ahead and go crazy with Dataverse because Dataverse storage is expensive. So you can control whether or not your developers can instantiate the Dataverse MCP directly at environment level. What happens if you turn that off? You save, and people already have that MCP server in their agent. So the only thing is it's going to refuse to answer the question. You will still be able to add that MCP server into your agent, but if I restart and ask the question again, it's going to go through the initialization of all my MCP server. It's not giving me an error for the Dataverse MCP server, but at the time of executing the tools inside that server, you can see here, this feature is disabled by my organization for my particular environment. So I have a governance control to enable or disable the Dataverse MCP server, which is kind of the risky one if you were to ask me. All right, next question would be like, hey, the first party servers are great. How do I create my own MCP server? To create your own MCP server, or to bring your own MCP server into Copilot Studio, it's a 3-step process. You create your server, whether you code it or use Azure for that. you publish it through a connector. That step is necessary. However, with Copilot Studio, there is a new experience in Copilot Studio where you don't have to create the connector manually inside the Power Platform. Copilot Studio will now build that connector directly for you. So if you go to your tool, add a tool, and you click on new tool here, and you want to create a new MCP server, you have an experience inside Copilot Studio where you put your name, your description, and your endpoint that you can retrieve from Azure, for example, and just hit create, and it will create the custom connector for you. You don't have to do that anymore. So it's a great new feature. So create the server, publish through a connector, whether you create the connector manually or you do that through Copilot Studio, and then you can consume it directly in Copilot Studio. The best way to get started with that, and if you want to play with an API that you own and expose that as an MCP server, go to Azure APIM, add your API as a managed API in Azure, and then with one click, you can create an MCP server on top of that API. You can select the different action in your endpoint that you want to expose in your MCP server, and then you can use that MCP server in Copilot Studio or elsewhere. If you want to add it in GitHub Copilot, in Cloud, anywhere else, you can. That's the beauty of MCP server. You can reuse them in other product and stack. If you want more documentation, I'll share with you the deck with some links. We have some decent hands-on lab if you want to create your own MCP server, play with different MCP server, expose them into Copilot Studio. That's where you want to go. All right. The last chapter of today's master series is about computer use. Computer use is very recent. It was in private preview up until last month. We just moved it to public preview. So now customers and organizations around the US for now can use computer use in Copilot Studio. So agent in Copilot Studio can interact with any system that have a graphical user interface. So in Copilot Studio, you can add a tool that will be computer using computer. You can use that in an autonomous agent. Technically, you can use that in a conversational agent, but we will see that computer using agent has some performance limitations. So I highly discourage you to use computer using agent for conversational agent. It's mainly designed for autonomous agent. When you add your computer use in Copilot Studio, you will have to configure it as a prompt. Or inside the tool, there is a prompt where you explain the agent what you want to do with the graphical user interface. Open Edge, enter a website, click on the search button, scroll down the page down to a particular section of the page, and extract the content of that web page, for example. You can see the prompt executing in real time with what's happening on the computer. So you will see in the demo that you have real-time update of what's going on. It's a little bit slow because it's screenshot based. I will get that in a second, but you can see that happening in real time. And then in the activity tab of your agent, you will be able to see the history and the previous run of a computer using agent. So how does it work? We enter a prompt to tell our agent what we want it to do with the computer. And the computer will take screenshots and determine an action based on the prompt and the state of the screen. So we are using a vision model to understand what's going on the screen, just like a human would read what's going on the screen. Then the agent decides to press a particular button by using the mouse. It's not based on the UI tree. It's actually based on the object that the computer sees on the screen. And then the computer will execute an action. So let's give it a try with a demo, and then I'll show you, I'll explain when to use CUA versus when to use regular RPA. So I'm jumping to an environment that has computer using agent activated. If I go to my tools, I will see here the computer use kind of tool. If I click on it, I have two options for the computer use. I can either use a hosted browser, so I only instantiate a web browser because all of my interaction is based on the web. Or if I want, I can provision a virtual machine and have full control on my tools with a virtual machine. So I can actually have a hosted machine. If I go to Power Automate, create a hosted machine, or if I want to bring my own virtual machine and connect it to Power Automate, I can then use that in my computer using agent. For the demo today, I just want to do a lookup on a website that doesn't have an API, and I want to scrap information from that website. So the way I do that is via instruction. I will tell my agent, go to that particular website, enter a particular value that is going to come from my input. So the portfolio is going to be, portfolio ID is going to be something coming in as an input for my agent. Retrieve, like search on that website, retrieve some information and return those information back to the agent. So if I want to see that prompt in action and refine it to make sure it works correctly, I can hit the test button here. Oh, I need a portfolio data here. Do I have one? Of course, I forgot to write down the portfolio. Oh, maybe it's in my, hold on, in my thing, in my story. No, sorry, bear with me 1 second. I need the portfolio ID for that. Oh, I can just get it from my previous run. Beautiful. So if I go to activity, I'll look at the previous execution of a particular flow. And this is an autonomous agent, so I'm actually getting data via email. But I just want to show you how you are able to test that CUA directly in the prompt. So here, it asks for an input. I'm going to manually give it an input, and then it's going to instantiate the computer using agent. So bear with me, it's a little bit slow because first it has to spin up a virtual machine in real time. So here you can see it's giving me the activity in real time. Since it's a limited preview, we don't give you unlimited virtual machine as part of your Copilot Studio entitlement. So there is a limit of 1 machine per environment or per tenant. I don't remember exactly. So my CUA instance has to wait for any potential other CUA to execute. So here I can see the virtual machine pop up on the screen. It's a screenshot, so I don't see the mouse moving in real time, but I will see what's happening step by step in my agent. So here it's opening my browser to access the portfolio. So it's going to go with the default web browser on my agent. So you can see here, it's going to open Edge. In Edge, it's going to locate the URL bar and it's going to send the website. So you can see here, accessing user-provided portfolio website. So it's explaining the reasoning behind what's happening the CUA. So I can see my URL from my instruction being entered in the website. Agent sees that, oh, now we are on the website. What should I do next? Enter the portfolio ID in the search field and click on search. Okay, pretty straightforward. So it's going to go into the portfolio ID, enter the number I gave as an input, hit search. It's going to filter that website. And then I'm going to return that data to, to my main agent. And then we can do whatever we want on that data. And you can see here, it's able to extract what I want, the client name, the portfolio value, and the manager inside the context of the prompt. So if I were to use that, I'm going to hit finish testing, use that computer using agent in an autonomous agent, my portfolio lookup agent is actually autonomous. So it's triggered when an email arrives. And I'll show you an activity where I sent an email earlier to speed the demo. So I sent an email to my inbox, and you can see here, show rationale. It's explaining why did I start this computer using agent, because I was able to understand that the user wants to look up the portfolio. And then it's replying to that email because I have a tool to reply to that email. And if I open my Outlook mailbox, you can see here that was an autonomous agent using computer use to get to a website that doesn't have an API extracting the value and replying to the end user via email with that information. So you are bridging the gap between multiple tech stack here to interact with a user via email. Let me jump back on my presentation. Some scenarios, very standard for CUA, data entry when you don't have access to that system, data extraction for a public website, for example, you don't necessarily have an API for this, or to move data between legacy app on a computer. The first question I get when people ask, when should I use RPA or when should I use CUA? So first, you have to understand the difference between RPA and CUA. RPA is rule-based. You define that in Power Automate. You have your desktop flow. You open this, you do that. The CUA is LLM-driven. You give a prompt, and the agent is going to figure it out. It's going to interact with the system via a vision model, and not the UI tree. That brings a ton of flexibility, because if the UI changes, if the button is not at the right spot, or the label is different, the large language model, the vision model, will be able to take that into account. I was doing that demo last week at a bootcamp, and Edge received an update and got me a pop-up in the middle of the screen saying, here are all the new features in Edge. Click OK to continue. I was running a computer using agent demo on top of that, and it couldn't access the URL directly. It had to click on the OK button to bypass the pop-up and then be able to go to the URL. After a few tries, the large language model detected, or the vision model detected, that the pop-up was not going away, read the instruction of the pop-up and hit OK to close that pop-up and continue the execution of my demo without me having to do anything. It was amazing. For CUA, everything is based from visual cues. It has very high flexibility, just for like this example of being able to close a pop-up that is unexpected in your scenario, and it will self-correct. So when do you want to use one or the other? So if you want to go with something that is GA, that is using a UI that is completely stable and it's not going to change anytime soon because you control that UI, when the rules are clear, when you want speed, high volume RPA is the go-to for that. And if you have an RPA team already there to build you, a desktop RPA, use that. So that's when you can use RPA, when this is great. However, CUA is great when you don't control the UI that you're accessing. Maybe it's a public website and you don't control the changes on that. Or you want to go fast and the RPA team backlog is completely full. You need to have a quick RPA to unblock your project and have some automation that anybody can write. It's very easy to write a prompt. It's much more difficult to write a complex automation in Power Automate Desktop. When the task is depending on vision, like the charts, the color, or a dynamic layout, CUA will be able to handle that because it's a vision model. And sometimes when the decisions are unclear because of a pop-up that shows up on the screen for some reason, the agent must think and decide what to do automatically and self-learn and self-correct. CUA is absolutely great for that. CUA follows the same boundaries than the rest of the Power Platform. So it will run within your Azure boundaries. And if we use a vision model, it's running inside your tenant and we run an OpenAI model at the moment. Your data is your data. We don't use it to train the model or improve the model. All the data is encrypted, both in transit and at rest. You have audit capability, so you'll have the screenshot of everything that is happening behind the scene. If you go back to the activity tab, actually, I wanted to show you that because it's super cool. If you go back to the activity of a CUA agent, you can see here the activity map, but you can actually switch to the transcript view and see the history of the screenshot. So you can see here my email coming in, and you can see the different screenshot and the reasoning from the vision model to go and accomplish the task. So you can audit what's happening. You can control machine, and in those machines, you can decide which website you want your developers to use and not use. You can have allow list, which application you allow CUA to control. Maybe you don't want CUA to go on SAP and go modify all the terms and the contract. Maybe you can limit that with CUA. And CUA goes through the same responsible AI that we use in all of our AI products. So it goes through a very thorough review and red team testing to make sure the model is behaving within the safeguard. Couple of features and roadmap item coming up. You can have ready-to-use machine, hosted machine, or you can use VM for public web automation if you want. So you have the two options. We can use credential that you store on Azure Key Vault if you want. We have allow list to restrict what CUA can do in website and application. We give you samples, an example of prompt that CUA will be able to use to extract information, to manipulate information, etc. Right now, it's only in the US. We are expanding region availability. It's only based on GPU capacity at this point in our data center. And computer use in agent flow is something that is coming up soon. I don't have an ETA, but we have big conferences at the end of October and beginning of November. Stay tuned. I'm sure there will be a ton of announcements there. And with that, if you want to learn more, go to aka.ms/MCSQA. And that's it for today.